hour. I'm sorry, it's 8 miles an hour. You'll hear me say 10, but it's actually 8. I have the wrong information. And you can watch the speedometer and notice its behavior as I'm.
All right, this thing should stop me at 10 miles. All right, this thing should stop me at 10 miles an hour. Here, gauging. It's definitely slowing me down. You can see it's back down to 7. Back up, just at 10, it's taking me back down. Brake is releasing. So it actually drops me a little bit below the speed that we set it at. I'm going to pedal again. We're up to 10.11. I'm going to keep pedaling. And it's actually getting a lot harder to pedal and my speed is still dropping. You can see we're 8.9. So, works pretty well.
On the next slide, what we did was we read the values on the speedometer, we plotted them against time, and you can see what happened. We ran 2 tests. One of these was Nick, one of these was myself. He's going downhill, he's just very easy pedaling, basically coasting. You can see that our system actually maintains pretty close to our specified speed. This is when he starts pedaling a little bit. You can see it spike a little bit, but then it starts to drop again. For the second test, we were pedaling a little harder. And you can see where we started, come up, there's a little bit of overshoot, system comes back down, pedal a little more, pedal a lot more, and you can basically see we're maintaining this average. This orange line is our average measured miles per hour. So it's fairly effective. Another worst case scenario test, we put Nick on it. He weighs 154 pounds. We found the steepest hill we could find that was in our vicinity. We told him go downhill and coast, see how it worked, and once you were satisfied with it, start pedaling, and then see how it works. So you'll see what's going on as he narrates the video.
This is the test down the steepest grade hill we can find on one to both. Miles, 7. We're looking for 10 miles an hour to slow us down. Here we hit 10, 11. Still not pedaling. I could feel myself slowing down. Now we're back to 10, our desired speed. I'm going to start pedaling now. You see the hill we're going down. It's getting harder to pedal. We're at 11.69. System's still engaging. I could feel the brakes. Hard to pedal. We're at 11. I'm going to try to pedal as hard as I can. Still keeping us 14. Back to 10. Now we're at the bottom of the hill.
So as you can see, under worst case scenario, it's it still keeps him at a reasonable speed. Under normal operating conditions, it actually works quite well. So we plotted, we read the values off of his speedometer, we plotted them against time. You can see what happens. Here's where he starts. As you can basically see, this is when he started pedaling really hard. He got up to just a little over 14. Starts dropping back down. When he was at the bottom of that hill, you could see he wasn't going as fast as he would have been otherwise. So, and then we had to test the reliability. We needed to know to what degree can we count on the system. So, when Nick was riding the bike home, he deliberately engaged the system 30 times, and he actually counted 30 out of 30 times the thing engaged and slowed him down again. So the system's highly reliable. It worked perfectly during our test. Now, we do know that there is a little bit of a bug left in it because when the voltage in the batteries drop low, what can happen is the motor slips, and then it thinks it's wound, but it hasn't, so it ends up unwinding too many times and causing slack in the string. We have to retune it. For our test, though, it was really went perfectly. So, we're calling that a success. As far as engaging at the correct speed, we actually already determined this during the speedometer test because the way that we knew the Arduino thought it was going at the specified speed was because the motor engaged. So when we heard that engaging, we knew that we were at the speed that we had specified. So. We interviewed the kid. You guys might have some questions about this. You'll hear him here about safety and general user interface.
I got a couple questions for you. Okay, first off, did you ever feel out of control or unsafe?
No.
No? Okay, were you ever distracted by it? Like, oh my god, what's happening?
No.
No, you're alright? Okay. Could you feel it significantly slowing you down?
Yeah.
Yeah? And then was it hard to bike even though the brake pedal was engaged?
Yeah.
Yeah, so it got hard and it was active. Alright, sweet.
Excellent.
As far as our prototype costs, this is basically the method that we use. We just lined everything up, everything we needed. We got the costs, took a sum. Our prototype ended up costing $277. For the production side of things, when we're actually producing it, buying things in mass bulk, we switched some components. Our Arduino microcontroller went to a different microcontroller that cost only $1. So we're looking at from $30 to $1. That dropped the price significantly. There were several components that we could do that with. So as far as our specs are concerned, we showed you, we talked about the reliability test. It was really good. We told you $3.96 a unit, so we met this spec right here. I showed you the video about adjusting the tire radius and the cutoff speed. We can do that too. As far as playing, everything went pretty well. We fell behind schedule once or twice, but we got to make up for it in other areas, so we actually finished a little bit ahead of time. As far as future plans, we want a more compact design. You guys will see this in a second. It's kind of bulky, but it's very possible to produce as a real product. So we're done. So basically, you guys come down. We want you to see the product. You can go and crank the tires and things like that. So just come play with it, see that it works. And if anyone has any questions, we'd be happy to answer.
I'll take 100. Put it in my store.